Welcome to School Page Video Teacher. Tenth CPSC Physics, Chapter Reflection and Refraction of Light. After watching this video, you will be able to understand the power of a lens and some numerical problems based on power of a lens. Let us understand what is a power of a lens. We have studied two types of lenses, a concave lens and a convex lens. We know that a convex lens converges light rays falling on it, whereas the concave lens diverges the light rays falling on it. So the degree of convergence or divergence of light rays achieved by a lens is expressed in terms of its power. So the degree of convergence or divergence of light rays achieved by a lens is expressed in terms of its power. Hence, the power of a lens is represented as capital P, which is defined as the reciprocal of its focal length. So this is the formula for calculating the power of a lens. Here the focal length is measured in meters. Since the power of a lens is inversely proportional to its focal length, a lens of short focal length has more power, whereas a lens of long focal length has less power. So a more powerful lens is the one that bends the light rays more and has a short focal length. That is, a thick lens has short focal length and more power, whereas a thin lens has long focal length and less power. The SI unit of the power of a lens is diopter. Diopter is denoted by the letter capital D. So 1 diopter is the power of a lens whose focal length is 1 meter. So on substituting the units in this formula, power is equal to 1 divided by focal length. So that is 1 diopter is equal to 1 divided by 1 meter. It can also be written as 1 diopter is equal to 1 meter inverse. The instrument used to measure the power of a lens is called as Diopter Meter. Hence, this instrument is used by opticians to measure the power of spectacle lenses. The power of a convex lens is positive, whereas the power of a concave lens is negative. So when an optician, after testing the eye of a person, prescribes the corrective lenses of say plus 1.5D and plus 1.5D, this is for left eye and this is for right eye, the optician actually refers to the power of convex lenses required for making eyeglasses or spectacles to enable the patient see clearly. And if the optician had prescribed the corrective lenses of say minus 1.5D and minus 2D for left and this is for right, so here he actually refers to the power of a concave lenses required for making spectacles. Let us solve few numerical problems to understand the power of a lens. In this question, a convex lens is of focal length 5 cm. What is its power? Focal length is given, we have to find out the power. So let's note down what is given in the question. Focal length is given as 5 cm. In order to calculate the power of a lens, we need its focal length in meters. But here the focal length is given in centimeter. So we should first convert the focal length into meters. So 5 centimeter is equal to 5 divided by 100 meter. It is 520 times. It is 0.05 meter. Now by substituting the value of focal length in the formula for power of a lens, which is given as power of a lens is equal to 1 divided by focal length. So this will be equal to 1 divided by 0.05 meter. After further simplification, we will obtain power of a lens is equal to plus 20 diopter. Thus the power of this convex lens is plus 20 diopter. The plus sign with the power indicates that it is a converging lens or a convex lens. In this problem, let us find out the power of a lens for a concave lens. The focal length of a concave lens is given as 2 meter. The focal length of a concave lens is always negative, so focal length will be minus 2 meter. By substituting the value for focal length, let us find out the power of a lens. Power of a lens is equal to 1 divided by focal length, which is equal to 1 divided by minus 2 meter. Hence the power of a lens is equal to minus 0.5 diopter. Thus the power of a concave lens is minus 0.5 diopter. In this question, a lens has a power of minus 5 diopter. We have to find the focal length and nature of the lens. So power of a lens is given as minus 5 diopter. Since the power of this lens has minus sign, so it is a concave lens. So using the value of power, let us find out the focal length. Power is equal to 1 divided by focal length. So minus 5d is equal to 1 divided by focal length. So focal length will be equal to 1 divided by minus 5d, which is equal to minus 0.2 meter. We can also convert this into centimeters. So then focal length will be equal to minus 20 centimeter. Hence we have found out the focal length of the lens to be minus 20 centimeter and the nature of the lens is a concave lens. The optical instruments consist of a number of lenses. They are combined to increase the magnification and sharpness of the image. The net power of the lenses placed in contact is given by the algebraic sum of the individual powers. That is, capital P will be equal to P1 plus P2 plus P3 and so on. So this is the net power of the lens. Example, if a convex lens of power plus 5 diopter and a concave lens of power minus 10 diopter are placed in contact with each other, then their resultant power will be written as P is equal to P1 plus P2. That is, net power is equal to convex lens is given as plus 5 diopter plus concave lens is given as minus 10 diopter. So if we add these two, we get minus 5 diopter. So this is the resultant power. So we have noticed that the combination of convex lens with a concave lens behaves like a concave lens. So according to the question, a convex lens, when combined with a concave lens, the resultant lens which we obtain will be the combination of both concave lens and convex lens. We should have noticed while eye testing, an optician puts several different combinations of corrective lenses of known power in contact inside the testing spectacles frame. The simple additive property of the powers of lenses can be used to design lens system to minimize certain defects in images produced by a single lens. Such a lens property, consisting of several lenses in contact, is commonly used in the design of camera lenses, microscopes and telescopes. Let us quickly summarize what we have learnt in this video. The power of a lens is the reciprocal of its focal length. The instrument used to measure the power of a lens is called Diopter Meter. The SI unit of power of a lens is diopter. A thick lens has short focal length but more power, whereas a thin lens has large focal length but less power. After watching this video, you should have understood the power of a lens and some numerical problems based on power of a lens. Thank you for watching. For more videos, visit our website videoteacher.schoolpage.me.